I'm honored to be here. I'm Stefano, Lena, product manager of our Economizer product line at Schneider Electric. And my very fast presentation to the hour is about where are we going with the data center cooling technology and trends, given the fact that we are asked to be greener than ever in the data center energy management and cooling. We strongly believe at Schneider that the future of the humankind will be electric from an energy perspective, and we strongly believe that within the 2030 IT will be the most demanding electric application, and electrical vehicle revolution will boost this more. In the parallel, we have a good development in the solar electrical production, but let's say that while we are waiting for this, we have to do something today, now, because we are requested to have 1.5 more electrical energy for all the applications all around the world, but we are asked to cut half for our carbon dioxide emission. And how we can achieve that in a short time without replacing all the hardware that we have already installed and that is operating. The only way to do that is efficiency. We need 3 times the efficiency we have today in our electrical equipment. And the first, easiest, fastest and reliable way to achieve this is to use better the energy that we have today available. And the only way to do that is to measure how good our equipment is performing. And this can be done only measuring, collecting data. So what Giuseppe said before, the data lake that we can collect using a software platform that connect with a connected product. We at Schneider have almost all connected products. The ones that are not connected, they will be very soon. And the new one that we are going to release are connected to our cross-platform. It is a cross-platform, a software platform that collect the data, analyze this data, and take action based on the insight of this data. The platform is structured in 3 different layers. The first one is the connected product. The second one is the edge, where all those data are monitored and presented to the end user with different dashboards. And the third one, that is the most important one, is where data are transformed in information and smart actions, leveraging artificial intelligence, leveraging our experience, looking for every efficiency possible with the current hardware, because the most efficient energy is the energy that we don't use at all, and the large amount of this is currently wasted in inefficient operation of the current equipment. Looking to the data center designing process and requirement, the focus when we as engineer and designer or engineering company are asked to have is much more complex than in the past. In the past, the focus for a data center design project were just a few, maybe cost, maybe space, maybe one of the very few cooling technology available. Today is much more different. It's much more different because the data center designer has a lot of input from the end user or the collocator company. The data center must be today ready for the huge amount of data that we don't know how much will be in the future, but we have been asked to be ready for something unknown today. It has to be sustainable because it's a social pressure to be sustainable, and some companies want to be sustainable, so they ask to us, they want a sustainable data center. They want a very, very small latency. good bandwidth. They want the data center placed geographically in a, let's say, comfortable place for the end user to manage it or to have access to the correct amount of electrical power that today means, could means several tens of megawatts. From a design perspective, all those requests means that the designer need to manage all those different aspects. Cooling typologies today are not just few options. We have many different well-established options and technology. There are different local and global regulations to be complied with. The end user is obsessed with the white space optimization and utilization. And we are facing a trend in using higher temperature in the data center for a lot of reasons that we will see follow in the next slides. And often we are talking not just about one room or several rooms or a big room, but we are talking of an actual building. And that building needs to be compliant not only with the data center requirement, but also with the building requirement. How all those aspects are translated in numbers, because we as engineers are required to comply with numbers. And despite the fact that in the past we should face some, just a few numbers, today those numbers are much more. So we have a requirement written in sort of value of water usage, PUE or partial PUE. We have CAPEX and OPEX number. And all those numbers are not independent from each other. We are asked that all of them are related in the proper way from the customer and or the end user point of view. That means that there are a lot of challenges for any operator in the data center industry, especially for the designer or the engineering company. Our contribution as Schneider with this presentation is to find a classification which are the top 6 challenges or opportunities in the data center field today. We start backward from bottom to the top. Number 6 is the refrigerants, new and alternative. This is an old story, started more or less 20 years ago. I'm old enough to remember when spray air has been banned because they are not good for the environment. For sure, the different protocols signed in the past, globally, with a small exception of a couple of countries. For sure, in the next future, the current refrigerant or the refrigerant that we were used to use will change completely. It's not something we can avoid, so it's something that we have to manage. From an historically perspective, once upon a time there was just one refrigerant, good for all. Today is not anymore. This is a short storyline of what happened in the world of the refrigerant. The first fork happened in the 2005 when two type of refrigerant was established, the R410A for the square compressor and the R134A for the bigger compressor, screw and variable speed compressor. But today we are experiencing multiple forks because the trend is looking for lower GWP refrigerant. There are some of them, but with the low GWP there are some side effects. Not all of them are manageable or add complexity when selecting a cooling unit with one of these new refrigerants. You can see the GWP value on the right side here of the boxes. let's say that the R1234ZA is a very promising one from a GWP perspective. Indeed, is likely the evolution of the 134A, but it's slightly flammable. So it could be a problem when we have to face fire regulation. And despite the fact that the efficiency is more or less the same, so no problem with this, GWP is good enough. But the main problem is the cooling capacity. Cooling capacity with this refrigerant is 20% less with the same chillers, let's say. So, and then we can say, so change it, use another one. It can be, but the side effect is that I will have a bigger GWP, so most likely I'm not ready for the future. And the most important point is that the envelope of this refrigerant is not suitable for the data center application that require very high temperature. And for instance, in the case of the alternative of the R410A, the problem is, for instance, that the R32 hasn't a good envelope, because for the comfort application is fine, but given the envelope required for the data center application, R32 is not the good one. We have to use different kind of refrigerant, like the two that are on the right chart. And let's move to the fifth challenge. Fifth challenge is the evolution of the worldwide energy standard. We are pretty sure that in the next future they will become more severe, even in the data center industry, as the colleague from Ashray mentioned before. There are several of them that we have to be compliant with, or that we have to be compliant in the next year. And those different requirements for a company that works globally could be very, very, very difficult to find a solution that satisfies all of them. Maybe something that is fine for one is not good enough for another one. Luckily, I would say that those are improving, and they are underlining a good differentiation between comfort and industrial application, or they are tailoring the requirement for the specific data center features. But for sure, from a technology perspective, the impact is that we have to change the operating condition of the data center and of the unit to be compliant with those standards, with those requirements and technologies, with the component inside the cooling equipment need to be changed toward more efficient technology like variable speed drive technology for panels and compressor. Let's mention that there aren't only bad news, but also some good news. There are some technologies that today allow to be compliant with the most severe standard efficiency. For instance, using a variable speed compressor in a chiller today allows to achieve plus 60% of say the minimum energy efficiency requirement set for the 2021 in the biggest range of cooling capacity for the chillers. So the point is, adopt today the best technology in order to be compliant for the future, because cooling equipment has not the same turnover as the IT equipment. I cannot say that the chiller is for all the time, but for longer than a rack for sure. Number 4, thanks to Giuseppe to mention before, the holistic approach. We strongly believe that one way to afford this challenge is to have an holistic approach. Design the data center with an holistic mindset. It's not a straight path, it's a circle. And it's a circle that is iterating very fast during the development of just one project, because every decision we take in one circle impacts the others. So the hope is that the process will converge to a trade-off solution. Let's keep a couple of examples of the four main points. The white space obsession of our end customer, how to minimize the impact of the cooling solution. Well, the king is the air economizing solution. An air economizer has zero impact in the white space, so it's fine. But the problem is that you cannot use everywhere air economizer solution because temperature, because maybe you don't have the right condition over all the year. So it's a good solution, but not always, not for every data center. So a good old room conditioner unit, a crack, can be optimized. Yes, it can be. This is a survey, an investigation that we have made in the last 20 years in the same footprint. A room condition unit achieved an increase of the cooling capacity of 57% and 30% in the last 3 years. So even a good old room cooling solution can save white space. And again, variable speed technology can unlock the chances to use trim technology that we will see later. Trim technology means that I can downsize the size of the compressor. It means to have an electrical infrastructure smaller, cheaper, simpler. The comparison here is about the standard unit and a unit with a trim cooling, a free cooling together. So it's achievable a reduction of the 40% on the mechanical dependency, the mechanical cooling, rather than use a compressor. So the capital expense will be lower, thanks to the reduction of the electrical infrastructure. This is an example, it is an actual example, where using a variable speed dry compressor with the same amount of electrical power available, it can be maximize the use of the electrical power for the IT equipment rather than the cooling. How much? More or less 30%. Or with the same IT power, electrical power, you can size a smaller power infrastructure. Again, I want to stress a little bit more the point in the comparison between a screw compressor to a variable speed drive oil-free compressor with the same cooling capacity. What's the comparison in the electrical infrastructure? The screw compressor can have from 1.5 up to 4 more cabling expensive, bigger up to 2 times circuit breaker, and main transformer and generator that does bigger than the variable speed one, thanks to the lower amperage with the variable speed drive compressor oil-free. So it's an actual opportunity that worth to be investigated. The third part, the mechanical. We said white space, we said electrical. What we can do in the mechanical part of the plant? We can widen the delta T operation. So in that case, we can achieve low water flow. In that way, we can have a higher delta T, higher return temperature. So we can unlock the possibility to use economization at higher temperature, rather than have smaller pump that use lower energy. And the installation can be simplified if we rely on prefabrication, pre-engineered, pre-designed package from a manufacturer that can deploy this kind of solution. We are at the podium. So what's the 3 top challenges? 3 top challenges are the size of data center. Are they becoming bigger or smaller? They are becoming both. We are facing bigger and bigger data center. They need to be approached with different strategy from an energy efficiency perspective. rather than the small one, let's say the edge, that is another very important trend that we are seeing in these days. The smaller data center, but with a lot of installation that can be achieved, need to be designed properly also from an efficiency perspective, because even a small difference per unit can achieve a global big result, because we would expect to have thousands and thousands of small data center installation in the edge. That's because service are changing in the IT sector. We are required to have data and computational power close to the end user. And silver medal, cooling size for higher temperature. I already mentioned before, at higher temperature, air, because Ashray told us you can design with higher air temperature. This allows to use higher water temperature. And higher water temperature means higher cooling capacity, means that I can use wider delta T, and thanks to the higher return water temperature, we can maximize economization. The chilled water unit means to have up to 60% of more cooling capacity with the same footprint, and on a room conditioned unit, more than 30% of reduction in power consumption of the fan. And for a chilled water means minus 40% in the size of the unit. And if you remember that with the new refrigerant, I have a unit that have minus 20% in the cooling capacity, but thanks to the higher temperature, I have a plus 40. It's still a 20% advantage that I can leverage on. And the air economizer is the king of the higher temperature, because if I allow higher supply air temperature, I can use the full economization in wider external temperature condition, up to 6, reaching minus 12% in OPEX reduction, and plus 44% in cooling capacity with the same unit. And the winner is, I think you have already the answer, the winner is that the solution must be economization based rather than cooling based. And what that means? It means that before I select a chiller and then I choose a free cooler to support the chiller. Now it's the opposite. I select a free cooler to do the main part of the cooling, and then I select a small chiller in order to support the free cooler when it's needed. This requires a lot of trade-off, but those are trade-offs that can be achieved and must be investigated using, for example, simple instruments like this matrix. In the top left, we are in the best condition. We have water available for cooling, for adiabatic and evaporative cooling, and we have lower external temperature, so we can rely up to 25% in mechanical cooling. In the bottom part, I lose water, I don't have water available, so the mechanical cooling raised to 50%. In the right top, I have the water, but I'm in a high temperature region of the world, so I can leverage evaporative and adiabatic. I would have 75% of mechanical cooling. And the bottom right, well, move your data center somewhere else. This is not a good place where to place a data center, because there you need 100% mechanical cooling. Our takeaway for you is guideline in how to face those challenges and how to try to win most of them. Design with economization as the baseline, and then adapt the trim part as small as possible. Use higher temperature to maximize the economization hour, and keep in mind that efficiency can be applied in different ways in big data center on the edge, and remember the scale effect. Design holistically using the circle and rely on prefabricated and pre-validated solution from vendor. The energy standard are a an opportunity to push the adoption of the most advanced technology in order to unlock efficiency. And the new refrigerant as not only greenwashing, is an opportunity, because overall is the best option to take care of our world. Thank you very much.